Welcome everyone to today's class. So today I'll be teaching us how to name inorganic compounds for my students in SS1 or SS2 that are yet to understand how to name inorganic compounds. So firstly, inorganic compounds, I think if you want to group them, we'll group them into basically number one, binary compounds. Binary compounds. Binary compounds are just compounds that have only two elements. That has just two elements. A good example here is the likes of CO, the likes of CO2, the likes of NaCl, and so on and so forth. So under binary compounds now is also subdivided into two. The first one we have, let's make that A. The first one we have binary compounds that have metals plus non-metals. Now naming a binary compound, what you just do is if you have a case of a metal and a non-metal, what you do here is this: the metal will retain its name. That means if you're naming a compound like this CO now, the C will retain its name, but of course C is not a metal in this case. So the metal will retain its name, while the non-metal IDE will be added to the ending. So the ending part of the non-metal, you change it to what? To IDE. Now let's take some examples. Now we have NaCl. NaCl is a binary compound formed from a metal and a non-metal, which is sodium and chlorine. Now sodium will retain its name as sodium. Cl, which is chlorine, will change the ending to IDE, and that will become what? Sodium chloride. We have changed the last part of it, so let me use red here. So sodium chloride. That's how to name it. Another example. Let's look at another example. I think we have the likes of CaO. So in this case, Ca is a metal, O is a non-metal. Ca is calcium, O is oxygen. Ca now will retain its own name, and which is what? Calcium. While the non-metal, which is oxygen, we will change it, or the ending we add IDE to it, and that will become what? Calcium oxide. With this simple formula now, I believe that you'll be able to name binary compounds that contains metal plus non-metals. Now let's check the second group under binary compound, which is non-metal plus non-metal. Now in this case, the rules are a bit different. The number one rule here is that when you're doing this, firstly, you must know that you will use what we call Greek prefixes. Use Greek prefix. And what does Greek prefix mean? In this, it just means that there's a name for it though. When it is 1, we'll call it mono. When it is 2, we'll call it di. When it is 3, we'll call it tri. When it is 4, we'll call it tetra. When it is 5, pent, and so on and so forth, just like that. So you use Greek prefix to pronounce the elements. That's the first rule. Let's go to the next page. The second rule now is this. In the second rule, you have a non-metal plus a non-metal, a non-metal plus a non-metal. In the first non-metal, if the first non-metal is just 1, you don't bother adding mono. You don't bother adding it. But if it's 2 upward, you must add the di. If it's 3, you add tri. Now, in this second non-metal, if this non-metal is 1, make sure you add mono. Make sure you add mono. If it is 2, make sure you add di. If it is 3, you add tri. Now let's try some examples ASAP. So number 1, we have the likes of let's use CO, which is a good example. CO. Now CO here contains a non-metal and a non-metal. C is carbon. Remember, in this case, carbon here has only 1, so there's no need of writing mono according to this rule. Then oxygen here, how many is it? 1. So you write it mono. Oxygen here will be what? Oxide. Carbon monoxide. That's the name of this compound, and that's how they got the name. Let's try another one. Number 2. Let's try CO2, a very common compound. The same way again here to the C will remain carbon, and there will not be any need of mono. Carbon. And the O2 here, 2 is di, so di. Then oxygen is what? Oxide. Can you see? Very simple. Let's try one more. In this case, we have the likes of let's attempt N2O4. How do we name this now? N is nitrogen, right? Now remember this rule now. This rule, remember this rule, right? So nitrogen, how many nitrogen atoms are there? We have two nitrogen atoms, and two is what? Di. So you put it there, dinitrogen. How many oxygen? Four, and four is what? Tetra. So dinitrogen tetroxide. Very simple. That's how to name it. It's as simple as that. Now I'm going to give a very fake example now. Not that the element, the compound exists, but let's apply it. A fake example now. Look at, if a compound is like this, N2, or let's say N3O2. So since there's 3 nitrogen, that will be what? Try nitrogen. Remember that the reason why this one is having its own full name, we explained in the first binary compound. The nitrogen is 2, that will be dioxide. It's a very simple rule, a simple pattern. So that's how to just name binary compounds. Now, I will use this next 3 to 4 minutes to teach you how to name acids. So, welcome back. Let's instantly talk about how to name acids. I've written it out already. I'll just explain all through. So, under acids are subdivided into two also when naming them. Of course, what are acids? Acids are just basically compounds or hydrogen-containing compounds. I hope you get that. But modern definition, we say acids are compound when dissolved in water produces hydrozonium ion or produces hydrogen ion as its only positive ion. The other definition of acid or the other concept of acid. So, but today we're just dealing with naming acids now. So the subdivision now, we have the first one here as binary acids. Binary acids are just acid containing two elements, which is always hydrogen and a non-metal. But in most cases, the non-metal is always what is it called? An halogen or a halogen, sorry. So an example here we have hydrogen and chlorine. So what do? Hydrogen changes to, if it's an acid, it changes to hydro, and then the halogen or the non-metal, you just put IC. From that place, you can call this one what? Hydrochloric acid. Simple like ABC. Tada! Then we have another one here, HF, hydrofluoric acid. Simple like ABC. Now the second category of acids are oxoacids, also called ternary acid. Now oxoacids are just acids that contain oxygen. That's just it. So in this case, they contain hydrogen plus oxygen and another another element, which is mostly a non-metal in most cases. Now I want to explain something here. You see, when naming oxoacid, the pattern we use in Nigeria, in our textbooks, likes of essential textbook, and I think there's also new school, is not the IUPAC with international pattern. However, it is also accepted. I wrote down some examples here, sorry, whereby this compound now has two different names. In our Nigerian textbook, this compound here is tetraoxosulfate 6 acid, a different pattern of naming using oxidation and valency. While IUPAC, the standard international standard part nomenclature, this is sulfate acid. This one is sulfuric acid. This one is nitrate. This one is nitric. So, whereas in Nigerian education system, this compound here is triazonitrate. That's triazonitrate 5 acid. Are we getting something here? So in this scenario now, I just want us to understand that this video is good for international students and the local students. For the local students, kindly keep on using the one that is accepted by our syllabus. Do you understand? So I think let's stop the video not to make it longer. So tomorrow I will continue from oxoacid. Thank you so much for watching. Don't forget to like, comment, and share. And don't forget lastly to press the subscribe button. Thank you and welcome to Nelson Learning Space.